The first idea of when a function is continuous is that you can draw the function without lifting your pencil, or you don't see breaks. Look at it over here. This is not continuous. Right here, it is very simple. Right here, yes, it's continuous. You can draw this function f without lifting your pencil. It's continuous. Same over here. Same over here. It's very simple. It's one of the fundamental ideas of calculus that you can do it without, you can understand it without problems. Here is more visualization. Look, I have a hole right here. Okay, look at over here. But the function is defined over here. I have a hole right here, but the function is defined over here. So this is interesting, no? But I think the function is not continuous. And this is the mastering level. Okay, so that's what I want to start with this lecture number 5 about continuity. You cannot draw something that is continuous having jumps or breaks. So basically, this is the visualization of continuity. So let's see what is next. No? Look at this. Is the function f of x continuous on the open interval -7, -8, 7? No, because we have a hole here. So we're going to put no. It's not continuous. Between 4 and 8, 4 and 9, we have a hole here. So the function is not continuous on that interval. Between 1 and 8, yes, the function is continuous on that interval. Is important what happened at 4 and 8? No, because they're not included. So between 4 and 8, we have a hole here. It's not continuous. Between -8 and 0, we have another hole there. The function is not continuous on that interval. So this is another important aspect of continuity in calculus. In the interval, open interval, -7, 8. -7, 8. We have a hole here. It doesn't matter. Look, it doesn't matter because those are the extremes of the interval. -7, we have a hole. In 8, we have a hole. But it's an open interval, so they're not included in our analysis. So the function is continuous. Be careful with those tricky questions. Look at the -7 right here and 1. Yes, the function is continuous in that interval. So summary here, when you are finding or when you are determining continuity in an open interval, it's not important the extremes of the endpoints of the interval because they are not included. -7, for example, right here has a hole, but it doesn't matter. And 4 has a hole, it doesn't matter. But even that, we have a hole here at -3, which is part of the interval. So this function is not continuous. Very easy, no? Now let's summarize this topic. A function g of x is continuous at x equal a. if all three of the following statements are true. Number one, g of x is defined at x equal a. Number two, the limit of the function g of x when x is approaching to a exists. And number three, the limit equals the value of the function. Super important. The function must be defined at x equal a. The limit of the function when x approaches to a exists. And the limit equals the value of the function at x equal a. Knowing that, you can answer every question in calculus about continuous functions. Let's see it. Don't forget the idea. The limits exist, the function is defined, and the function equals the limit at that particular point. This is a classic question. Find the value of k that makes f of x continuous at x equals 7. So this is a piecewise function, okay? And I have to find here basically the value of k. So when the function is not equal to 7, okay, the function is minus x plus 3. Let me find the limit when the x is approaching to 7. Okay, when the function is not 7, the function is minus x plus 3. Okay? When it's not 7, and when we're finding the limit, we don't care about what happened at that point, at that x value. So by simple substitution here, you can do the limit when the x is approaching to 7 from right and left, and you substitute by 7. Minus 7 plus 3. The answer here is negative 4. So the limit exists at x equal 7. Okay? So the value of k that makes this function continuous is negative 4. So k is negative 4. Why? Because remember the main conditions. The function is defined at x equal 7. The limit exists and the limit equals the value of the function. If the limit is negative 4 at x equals 7, so the limit of the function must be the same as the function evaluated at x equals 7. So the function evaluated at x equals 7 is k. K must be equal negative 4. This is the main core idea of continuous function. Those three elements. I hope you like the video and share the video. Don't forget to watch lecture 1, 2, 3, 4, and this is number 5 about continuous functions. It's a pleasure. And don't forget to join Math Topics for more resources, more interaction, and see you in the next video. Thank you.